Half of 156 is 78. Okay, now I could split these in half again due to the fact that they're both even. Half of 44 would be 22, and that would be compared to half of 78, which is 39. Now I know I can't go any lower than this because 22 does not share a common factor with 39, but one neat thing about this ratio is that it kind of diminishes the difference between these two numbers of losses to wins, which actually might be advantageous for somebody who's running this game and might not want you to think that possibly you are losing much more than you're winning. They might put this on a smaller scale. Now the last comparison statement they ask you for is a percent. Percent, okay? Thinking about a percent, we usually talk about the percent of spins that were wins or percent of spins that were losses, but that means out of the total amount. The weird thing about percentages is that they are very, very tied to fractions. So one thing I'll encourage us to do is actually write this as a fraction first and then convert it to a percentage. Here's what we'll write, okay? As a percent, we could say that 88 out of a total of 244 spins were wins, okay? We say 88 244ths, or out of, okay, of course, of spins were wins. Neat thing about this fraction, of course, is that they are both even, the numerator and the denominator, and we can reduce these both by a factor of 2. Splitting these in half, you might notice that, and I'm just doing this as side work, you would have 44 as half of 88, half of 244 is 122. We can actually split these in half again. That would be 22 over half of this would be 61. Now, I might be mistaken, but I think 61 is a prime number, and therefore these will not share another common factor. But 22 out of 61, the reason why I reduced these was to work with simpler numbers. Now here's the deal. When you have a fraction, you want to convert it to a percentage. What you need to do is take the numerator and divide by the denominator. This can be something we do off to the side, and as a matter of fact, I'm going to ask you to check your work on a calculator. I do want to see your work though. So showing this work, how's about right here? We say 22 and 61. We know, of course, 61 doesn't fit into 2, and nor does it fit into 22. Of course, we can expect to get a decimal out of this, but building out a decimal, here's the neat thing about it. This becomes pseudo 220, but I know 60 would go into 220 about 3 times, and the reason why I know this is because I say this is about 60 anyways. Okay, so 60 going into 220 is kind of like asking how many times 6 goes into 22, and 6 times 3 would be 18. So here, let's put a 3 up here. Of course, 3 times 61 actually produces a product of 183. The difference between these two, and we'll go ahead and borrow up here, we say 10 minus 3 is 7. We can't take 8 away from 1, we'll borrow from the 2. 11 minus 8 is 3, and of course this is 0. We would have to keep going here. Now because I want a percentage, I don't have to keep going on forever and ever, but I know that a percentage as a decimal goes out to the tenths and the hundredths spot. So let's go ahead and get this number here. I say, well, how many times would 61 go into 370? Okay, well, let's say this is a benchmark, 60. How many times would 60 go into 370? It's kind of like asking how many times would 6 go into 37. Well, I know 6 times 6 is 36. So we'll put a 6 up here. Besides the point here, 6 times 61 would be 366, and I know that it fits in. But that's besides the point. Now I've got enough evidence to support that this would be about 36%. So instead of saying 88 244ths of the spins were wins, what we were looking to do was to say that about 36% were wins. Now I know what I'm writing here is slightly crowded. You'll have more room on your paper, but what I need you to be doing here is when they ask you for a percentage comparison, you need to tell me how many wins out of a total, how many losses out of a total. Either way, you need to take that numerator and divide by the denominator and get your decimal. And we'll convert that decimal to a percent. So we know about 36% of the win, or spins were wins. Of course, taking 100 minus that would give us what percent were losses, as a matter of fact. Now moving on, Part B asks, it says, choose one of the methods of comparison from Part A, ratios, percents, or differences, and think of a situation in which this method would be an effective way to report the spin results. You know what a situation I might mention is, I'm not running a casino here, but maybe I'm running a game and I'm making money off the people that play. Clearly, you're losing more than you're winning, and that'll be the case on your problem as well. But one thing to point out is, well, if I'm going to give my customers data here, I don't maybe want to tell them the whole truth and nothing but it. I want to misrepresent the truth. So maybe I say, okay, well, let's look at the difference. You know, 68 more losses than wins, or 68 less wins than losses. Well, you know what, I don't necessarily want to tell you that, even though it doesn't tell you how many times that we've spun it so far. It does let you know that there's a big difference between wins and losses, and that clearly losses are on top. Looking up at ratios, you know what, maybe I will go with the ratio, but saying that wins to losses in a ratio of 88 to 156 isn't going to be very helpful here. But the neat thing about this, and we've already mentioned it, is that we can reduce this ratio. If you do this on your homework, you'll be able to reduce your ratio as well. Do it just like mine with your numbers. But the neat thing here is the difference between 22 and 39 is not as significant as the difference between 88 and 156. I probably would not go with the percent comparison in that situation, because I'm saying you only win about 36% of the time, and of course we know percent means out of 100, so that's 36 out of every 100 times, which produces that large difference again. So in my situation, I would go with a simplified ratio. Okay, now Part C says, explain how you could find the probability of getting a win in one spin of the spinner without using the data in the chart. Okay, without using the data in the chart. Probability sort of works like this. We say, like a coin has two sides, and we say, what's the probability of getting heads? My first question would be, well, how many heads does this coin have? And of course it has one. One out of how many total? Out of 2. So looking at that fraction, we would say in that situation it would be 1 out of 2, which is 0.50, which yields a percentage of 50%. We can theoretically say that 50% of the time it should land on on heads, and of course 50% of the time on tails. Looking at this situation, I would ask, well, what's the probability we get a win? I'm going to ask you, how many wins are there? Of course, on your wheel there's one win. On mine, there are 2. So I would say there are 2 out of how many total possible outcomes? 6. Okay, so I say 2 out of 6. And the neat thing about my fraction, and this would be kind of true about yours, is that it's easy to work with. Mine, as a matter of fact, reduces down to 1/3 since these are both even. And I know that that's 0.333. And of course, as a percentage, I could say 33% of the time. Now, this is kind of interesting because if you look at Part D of the problem, it's going to ask you how this theoretical probability, we should win 33% of the time, compares to the actual data. One thing we've already done, or I've already done on this problem, is I've actually worked out that given this actual data, 36% of the time, these were wins. And they're asking you, well, does this seem to agree with the theoretical probability? And the answer to that is yes. We should be winning this much of the time. As a matter of fact, these people are lucky, but they came out with their data winning 36% of the time. If you haven't already worked out a percentage of wins, on Part D, what I would suggest you do is you say, well, there were 88 wins out of 244 in this case, or you might say that you had 46 wins out of 236 total spins, and work that out as a percentage and compare that to what you found in Part C.